Let us discuss this example. In this example, we have a function t sine cube t. We have to find its Laplace transform. Okay. So see, you know that always we start from the right hand side. The first function is sine cube t, and after that its multiple is t. So t is there, so that's why I'm going to use effect of multiplication by t. Getting? But first of all, we have to find Laplace of sine cube t. Let us find Laplace of sine cube t. Consider Laplace of sine cube t. We cannot find its Laplace directly since cube is there. There is no any direct formula. So here we have to use the knowledge of trigonometry to simplify it further. Do you know the formula of sine cube theta? It is 3 sine theta minus sine 3 theta divided by 4. Let us write that formula here. So this is equal to Laplace of 3 sine t minus sine 3t divided by 4. So you know that when you have any constants, you can take outside, as well as if there is a subtraction, you can take separate Laplace transform. Same thing I am going to do. 4, which is a common denominator, so it is a denominator of both terms. 4 is a denominator of this one as well as this one also. So 3 by 4 is a constant, you can take it outside. Laplace of sine t, correct, minus 1 by 4, which is the denominator of this one again. So Laplace of sine 3t. So in this way, we have made them separate. After that, we have to apply the formula. Let me write here the Laplace of, I am writing the formula, sine at is equal to a upon a square plus a square. So this formula we have. I am going to use this formula here. Here a is equal to 1. And if you apply the same formula here, here a is equal to 3. So it will be like this, 3 by 4. Sine t, its Laplace is 1. So 1 upon a square plus 1 square 1 minus 1 by 4 into, when you apply the same formula here, here a is equal to 3. So in this case, we will have 3 by a square plus 3 square, which is 9. You can easily see 3 by 4 is here. Here is also you have 3 by 4. So you can take 3 by 4 common. So it will be 3 by 4. 1 upon a square plus 1 minus 1 upon a square plus 9. So this is the Laplace transform of sine cube t we have got. After that, we have to focus on t. So t is there, that means we have to use effect of multiplication by t, which we have already seen in our previous video. Let us do that. Okay, we have some space. Let us use. So Laplace of t sine cube t. So you know that what we do, we first consider the power of t. What is the power of t? 1. So that's why n is equal to 1. So effect of multiplication by t says you have to write minus 1 raised to 1, getting? So I'm not writing, and nth derivative, which is 1 again. Okay, so this is Laplace of sine cube t. Okay, derivative of Laplace of its neighboring function. So neighboring function is sine cube t, so that's why I wrote in that way. Okay, so I simply use effect of multiplication by t. If you want the formula or rule, you can see the previous video again. So this is equal to minus 1 derivative of, okay. So this task we have already done, getting? And already we have got its value. So let us put the entire value there at a place of Laplace of sine cube t. So it will be 3 by 4, okay. In bracket we will have 1 upon a square plus 1 minus 1 upon a square plus 9, right? So what will happen, that 3 by 4 is a constant, will come outside. So it will be minus 3 by 4, and you can take separate derivative. Derivative of 1 upon a square plus 1 minus derivative of 1 upon a square plus 9. Since you know that when minus sign is there, when subtraction is there, we take separate derivatives. I have done the same. So now the question is how to find their derivatives. So we have very simple formula, that is derivative of 1 by x, which is minus 1 upon x square. So I think same formula we have used in previous example also. This formula I am going to use for this one or that one also, since the basic format is same, 1 upon something. Here also we have 1 upon something, there also we have 1 upon something. Let us apply the formula. So this is equal to minus 3 by 4. Its derivative will be using this rule, minus 1 upon a square plus 1 bracket square. Getting? So after that, again we have to use chain rule and we have to take its derivative. So into derivative of this denominator again, s square plus 1. Since there is no single variable, there is a function. So by chain rule, we supposed to take its derivative again. I have done the same thing. Okay. So minus. So when you take derivative of this one, same thing we have to do. First of all, we have to use this formula to find its derivative. It will be minus 1 upon whatever the denominator, s square plus 9 square, into again derivative of s square plus 9. Okay, so this is equal to, let us finish it, minus 3 by 4. See, this term will be as it is, so simply we have to find its derivative. Will you tell me what is derivative of that s square plus 1? Derivative of s square is 2s, correct? Derivative of 1 is 0 since it is constant. So that 2s into minus 1, you will have minus 2s upon s square plus 1 bracket square. In this way, we finish the first term. Minus this minus minus plus we will have, right? So when you talk about this derivative of this one, what is derivative of s square? It is 2s. What is derivative of 9? 9 is a constant, derivative will be 0. Getting? So this 2s into this one, so 2s upon s square plus 9 whole square. Getting? So this is the required answer. If you want, you can further simplify. You can take that 2 common, getting from both terms. That 2 will get cancelled with this one. You can manage minus sign also if you can cross multiply. But this is also enough. So you can consider it as a final answer. Make a screenshot of it, then we will stop. Thank you. Bye bye.